Hello, welcome to this video. Today we are going to solve this problem. So we need to find all triplets A, B, and C, which are positive whole numbers. So A, B, and C are in Z bigger than 0. That satisfy 3 to the A plus 2 to the B plus 2015 equals 3 times C factorial. So first thing I'm going to do is apply mod 3 to both sides. And actually, no. Before that, I'm going to find a lower bound for C. So if I look at C, if C is 5, that means that 3 times C factorial is 3 times 120, which is 360. And this number is obviously smaller than 2015, meaning that C, which is equal to 5 or smaller than it, won't work. If I look at C equals 6 though, 3 times C factorial would now be 3 times 720, which is 2160. Which is indeed bigger than 2015, meaning that it's a possible value. So, in total, in summary, C is bigger than or equal to 6. We will use that. Now let's solve this. So let's apply mod 3 to both sides. 3 to the A is 0 mod 3. 3 times C factorial is 0 mod 3. 2 to the B is negative 1 to the B mod 3. 2015 is negative 1 mod 3. So this is negative 1 to the B minus 1 is congruent to 0 mod 3. Or in other words, negative 1 to the B is congruent to 1 mod 3, which means B is even. If B is even, I can set B to equal 2 times y, and y will still be a positive integer. So now, I have the following equation, 3 to the A plus 4 to the y plus 2015 equals 3 times C factorial. Now, I'm going to do something similar. I'm going to do mod 4 on both sides. 4 to the A is 0 mod 4. And since C is bigger than or equal to 6, C factorial is divisible by 4. So 3 times C factorial will be 0 mod 4. And so I'll get then mod 4 negative 1 to the A, which is 3 to the A. 2015 is negative 1 mod 4. So this is minus 1. Is congruent to 0 mod 4. So negative 1 to the A is 1 mod 4, which means that A is even. And so I can set A to be equal to 2x, and now x is a positive integer. And now my new equation will be 9 to the x plus 4 to the y plus 2015 equals 3 times C factorial. Yes, I'm going to apply mod 9 to both sides. C factorial is divisible by 3. So 3 times C factorial is divisible by 9. So this this side will be 0 mod 9. 9 to the x is 0 mod 9. So in total we'll get 4 to the y. And 2015 is negative 1 mod 9. So this is minus 1. This is congruent to 0 mod 9. Now, mod 9 is interesting with powers of 4 because if we look at a 4 to the power of something mod 9, we'll get this. So let's do this for the first, 4 to the second, 4 cubed, 4 to the fourth, and 4 to the fifth. So 4 is 4 mod 9. Then multiply that by 4 would be 16, but mod 9 is 7. Then multiply that again by 4. Well, you have 28, which is 1 mod 9. And then if you keep multiplying by 4, you get the same cycle. 4, 7, 1, 4, 7, 1, 4, 7, 1. And the only time you'll have a 1 mod 9 is if the power is divisible by 3. So in other words, y. So 3 divides y, meaning that I can set y to be equal to some 3 times z. And my new equation will be 9 to the x plus 4 cubed is 64, so plus 64 to the z plus 2015 equals 3 times c factorial. Okay, now I'm going to do a little bit of cases. So if c is equal to 6, which we know is its bare minimum, so the other case would be c is bigger than or equal to 7. But if c is equal to 6, we know that 3 times c factorial would be 2160. And then subtract 2015 from that, you'll get 145. So you'd have 9 to the x plus 64 to the z equals 145. Now we want to solve this, but as you can see, 64 squared is already way bigger than 145, and since z has to be a positive integer, z here, the only option it has is 1. So when z equals 1, 145 minus 64 is 81. So 9 to the x would be 81, and x would be 2. And so that is actually a solution. Remember, a is equal to 2x. So this solution is a equals 4. B equals 2y, and y is 3z, so b is 6z. So b would be 6 times 1, which is 6. And then c would be 6. So that is already one solution. Now let's do the second case. For c bigger than or equal to 7. If c is bigger than or equal to 7, we know 7 is included in the product of c factorial, meaning that 7 divides c factorial, meaning that if we do mod 7 to both sides here, this will be 0. 64 to the z mod 7 is like 1 mod 7. 64 is 1 mod 7. And 2015 is negative 1 mod 7. So we'll have plus 1, minus 1, 0. And 9 to the x is 2 to the x mod 7. So we'll have 2 to the x is congruent to 0 mod 7. Which is obviously incorrect. So c cannot be bigger than or equal to 7. And for c equals 6, we only have one solution, which is this solution. And so all in all, this is the only solution. Summarize, the only solution is a is equal to 4, b is equal to 6, and c is equal to 6. And finally, that's it. If you want more content like this, please subscribe to my channel. I'll be uploading more interesting content and things like this in the future. And finally, that's it.